right, number 39. So we have two hockey players. One hockey player is in motion. The other hockey player is standing there at rest. Okay? So what you want to do is you want to take the information given in the problem and put it onto a diagram so you can see it clearly. Okay, so skater number 1 is going to be the guy that starts at rest. Okay, so I'm going to label here V1 initial. So that's the way you read that, not V10. V1 initial is 0 meter per second. Okay, now skater 2 is moving with a constant speed. They tell us right here, a uniform speed. The word uniform and constant are interchangeable. Uniform just means constant. He's moving with the speed of 12 meters per second, and if his speed is uniform, that tells us something about his acceleration. If he's moving at 12 meters per second, not going faster, not going slower, what's the acceleration going to be? 0. Not going faster, not going slower, that's 0 acceleration. So I'm going to label that acceleration 2 for guy number 2. And then this is velocity 2 for guy number 2. Okay, so then what happens here? So guy number 2 passes guy number 1 who's at rest. Now, what does guy number 1 do? Guy number 1 waits for 3 seconds and then starts to chase guy number 2 with an acceleration. And we're given that acceleration. I'm going to call that acceleration 1 for guy number 1, and that's 4 meter per second squared. Okay? Now, will guy number 1 eventually catch guy number 2? Now keep in mind, guy number 2 is moving at a constant speed. Guy number 1 is accelerating. Right? So will guy number 1 eventually catch guy number 2? Yes. Okay. Now, we got to deal with the time. But so see right here, they say after 3 seconds, guy number 1 makes up his mind to chase guy number 2. So we got to somehow deal with that 3-second pause that guy number 1 had. Okay? But before we do that, I want to talk about these two insights. The time is going to be the second insight. So there's 2 insights into this problem. Dealing with the time is the second one. The first insight is this. Look, the problem begins at the moment skater number 2 passes skater number 1. The guy who's cruising at a constant speed passes skater number 1. Bam! The problem begins right there. Now, when does the problem end? The problem ends, so here's skater number 2, he's moving at a constant speed. The problem ends when? When skater 1 catches up to skater 2. That's when the problem ends. Bam! What's the first insight? Both skaters have the same, what? Distance or displacement. X, the displacement, is the same for both skaters. From start of problem to end of problem. They're both covering the same ground. Okay? Now the second insight has to do with the time. How can we deal with this time? So look, which guy from the start of the problem to the end of the problem, which guy has a greater time of motion? Guy 1 or guy 2? Remember, skater number 1 waits 3 seconds. He's just standing there. So who travels longer for a greater period of time? Skater number 2. So what I'm going to say for guy number 2 is I'm going to say time 2 for guy number 2 is equal to time 1 plus 3. Right? He travels 3 seconds longer. Or you could have said, up here you could have said T1 equals T2 minus 3. You could have said that. Okay? But we'll just do it this way. So the time for guy 1 is just T1. The time for guy 2 is T2, which is equal to T1 plus 3. Okay, so that's the second insight. T2 is equal to T1 plus 3. All right, now, to solve this, so what we're looking for, we're looking for two things. I'm going to erase this here, but we're looking for how long does it take guy number 1 to catch guy number 2, and then we're looking for how far did guy number 1 travel in that time. Okay, so here's how you do it. So we're going to write an equation. Now, the most commonly used equation, and it's the first equation on the kinematic list. The most commonly used equation is that first one. So I'm going to write an equation for guy number 1. So for skater number 1, I'm going to write out the first kinematic. X equals 1/2 acceleration 1 time 1 squared plus v initial t. Now, what was the initial velocity for skater number 1? This initial velocity here was what? 0. See down here? He started at rest. Okay? So I'm just going to erase this. It's 0. So the equation for skater number 1 is this equation. Now, let's write an equation for skater number 2. Okay, for skater number 2, x equals 1/2 acceleration 2 t2 squared plus v2t. What goes to 0 in this equation? If you look for guy number 2 here, the acceleration for guy number 2 is 0. So we can cross that to 0. You guys with me? Am I going too fast? Okay, so we're actually almost done. So this becomes, so what happened to this equation? It's now just x equals v2 times t2. But what's t2? Let's plug this in right now. t2 is t1 plus 3, so that's v2 t1 plus 3. So here x equals v2 t1 plus 3. Now, we have these two equations. We got an equation for skater 1, an equation for skater 2. The next step is to recognize insight number 1, which is that the displacements are the same. So can we substitute these two equations together? Yes. So here I'm going to erase, make some more room. So now we substitute the equation. So what we get is 1/2 a1 t1 squared equals v2 t1 plus 3, and then we distribute this. So the rest is just algebra. So this is 1/2 a1 t1 squared equals v2 t1 plus 3 times v2. Now I would say plug the numbers in. So a1 is what? a1 is 4. v2 was 12. 12 like this. So what we're going to end up getting, 1/2 times 4. So we get 2t1 squared equals 12t1 plus 36. So rearranging this, 2t1 squared minus 12t1 minus 36 equals 0. Uh-oh, we got a what? A quadratic. So here's what I got. I'll just show you. I went to this web page where you can plug in. So here we go. 2, -12, -36, right? By the way, the quiz on Thursday, I'm not going to give you any quadratics to do on the quiz. That would be like a free response. That would be like, you know, where you're showing your work. For a multiple choice quiz, I'm not going to have you solving quadratics, simply because it takes too much time to do it. Okay? So we have two answers to this quadratic, 8.196 and then -2.19. Now which one can it not be? The negative, because time is not going to be negative, so choose the positive. So the answer comes out as 8.196. T1 is 8.196 seconds, and that's the answer to part A. You can round that to the tenths place, right? Now, second question was how far did guy number 1 travel in chasing guy number 2? So to do that, you know, I would just go back to this. X equals 1/2 at squared plus v initial t. So focusing on guy number 1, What was the initial velocity of guy 1? 0, so that goes to 0. So we can figure out his displacement with the first kinematic. His acceleration was 4. We now have the time. Hey, should we plug in the rounded time or the unrounded? Unrounded. Don't round until the very end. So plug in 8.196 seconds squared, and then we get his displacement to be about 134 meters. So these are the two answers to the question. Any questions on this?